I know that 3 is less than M is less than 13. So that means M is the number of classrooms. So number of classrooms is in between 3 and 13. And we know that 13 is less than N. So that means I've got more students than classrooms. We know that N is greater than 13. All right, so basically what we're trying to figure out is it possible to assign each of the N students to one of the M classrooms? We're trying to figure out if the number of students, if N divides M. That's what we're trying to figure out, if M is a factor of N. All right, let's look at the clues. Clue 1 says 3N students to one of M. See, it is possible to assign each of the 3N students to M classrooms. So that means that M goes into 3N. Well, that's not going to work all the time, because if you let, okay, we can let N be 27. That's bigger than 30. That works. And if you let M be 9, 9's in between 3 and 13. We'll plug those numbers in. So you have 3 times 27 over 9. 9 will go on 27 3 times. That works. You get an integers. But I'm using the same numbers as the GMAT book does. You know, you can use a whole bunch of different examples. If you let N be 30 and M equals 9, does that work? So 3 times 30 over 9, well, that works, because 3 will go into 9 3 times, and 3 will go into 30 10 times. So that satisfies the clue, but 9 does not go into 30 evenly, so that doesn't work. So clue 1 is not working. What does clue 2 say? It says it's possible to assign each of 13 N students. Okay, so that means 13 N students, and is that divisible by M? Well, yes, I think that's going to work, because look at it like this. If you have 13 times N over M, excuse me, 13 is a prime number, okay? And M is in between 3 and 13. So you can't cancel this way. M does not go into 13. So this is the clue. They're telling you 13N divided by M is an integer. So to make 13 times N over M an integer, we know M doesn't go into 13. That means M must go into N evenly. So clue 2 works. Your answer is B.